Ask most people, including many Japanese people themselves, to describe Japan's population, and you will likely hear some version of the same idea. A single, remarkably homogeneous nation, one people, one language, one continuous bloodline stretching back deep into prehistory, largely undisturbed by the waves of migration and conquest that reshaped so many other nations across history. This idea of Japanese homogeneity runs so deep that it has shaped everything from national policy debates to popular self-image for well over a century. It's worth noting that this popular narrative of Japanese homogeneity has already faced meaningful challenges from a different direction entirely, quite separate from the genetic research this video focuses on. The Ainu people, an indigenous population living primarily across the northern island of Hokkaido, maintain their own distinct language, culture, and identity, separate from mainstream Japanese society, and were only formally recognized by the Japanese government as an indigenous people in 2019 after decades of advocacy and, at times, outright government denial that any meaningfully distinct indigenous population existed within Japan at all. Genetic research examining Ainu ancestry has found they carry a notably higher proportion of Jomon ancestry than populations found across most of mainland Japan, suggesting the Ainu represent a population that remained more directly connected to Japan's earliest indigenous inhabitants, while the rest of the country underwent the more extensive layering of Yayoi and Kofun migration. This newer genetic research has now documented in such detail. The Ainu story serves as a useful reminder that questions about Japan's genetic and cultural homogeneity were already being raised well before this particular ancient DNA study, though the specific discovery of hidden Kofun ancestry added an entirely new, previously unknown dimension to that broader, ongoing conversation. In 2021, a single genetic study quietly dismantled a significant piece of this narrative, not by claiming Japan wasn't distinct or cohesive, but by revealing that its ancestry runs through at least 3 entirely separate chapters of migration, one of which had remained completely invisible to scientists until modern genome sequencing technology finally caught up with the mystery. To understand exactly what changed, we first need to understand what scientists believed for the 30 years leading up to this discovery. Back in 1991, a Japanese anthropologist named Kazuro Hanihara proposed what became known as the dual structure hypothesis, built primarily from careful measurements of ancient skulls and teeth recovered across Japan. According to this theory, 2 distinct populations combined to produce the Japanese people we recognize today. The first were the Jomon, indigenous hunter-gatherers who had occupied the Japanese archipelago for many thousands of years, developing one of the oldest pottery traditions ever discovered anywhere on Earth, dating back an astonishing 16,500 years. The second were the Yayoi, rice farming migrants who arrived from the Asian mainland roughly 3,000 years ago, bringing with them metal tools and organized agriculture, and who gradually intermarried with the existing Jomon population until their combined descendants became the Japanese population we know today. For 3 decades, this dual structure model held up remarkably well, taught in Japanese schools, repeated in documentaries, and generally accepted throughout the scientific community as settled fact. Nobody seriously disputed that these 2 populations existed, or that their blending explained the broad genetic foundation of the Japanese people. The real question, the one that would eventually crack this model wide open, involved a much later chapter of Japanese history that nobody had previously thought to test genetically at all. That chapter is called the Kofun period, spanning roughly the 3rd through 7th centuries of the Common Era, named after the massive, distinctive keyhole-shaped burial mounds constructed for ruling elites during this era, some of which remain among the largest earthen monuments ever built anywhere in the ancient world. The scale of these monuments alone hints at just how much organized political and economic power had developed within Japan by this point. The largest surviving example, known as the Daisen Kofun, believed to be the resting place of Emperor Nintoku, stretches nearly 1/3 of a mile in length and required, according to some engineering estimates, well over a decade of coordinated labor and enormous quantities of earth and stone to complete, rivaling in overall volume some of the great pyramid complexes built in ancient Egypt many centuries earlier, even though it remains far less familiar to most people outside Japan today. Constructing monuments of this scale required exactly the kind of centralized authority, organized labor coordination, and accumulated wealth that historians associate with the emergence of true statehood. Precisely the transformation the Kofun period is already famous for representing within Japanese history, well before anyone thought to test whether this same transformation carried its own hidden genetic dimension as well. Historically, the Kofun period is understood as the moment Japan transformed from a collection of scattered regional communities into something resembling an organized, centralized state, complete with powerful ruling clans, extensive trade and diplomatic contact with mainland China and the Korean peninsula, and the eventual foundations of what would become the Japanese imperial system. For well over a century, historians studying the Kofun period focused almost entirely on its political and cultural dimensions, the rise of centralized authority, the elaborate burial customs, the diplomatic exchanges documented in surviving records from China and Korea. Nobody had reason to suspect this transformation carried its own distinct, detectable genetic signature, separate from the Jomon Yayoi population already established across Japan for centuries beforehand. The assumption, reasonable enough given the available evidence, was that Kofun period Japan represented political and cultural evolution built entirely on top of the existing Jomon Yayoi genetic foundation without any further wave of population migration involved. If you find it fascinating how a historical period study for over a century through political and archaeological evidence could still be hiding an entirely undetected genetic secret, go ahead and hit that like button. It genuinely helps this channel keep bringing you carefully researched deep dives exactly like this one. In 2021, a research team including scientists from Kanazawa University and Trinity College Dublin decided to test this assumption directly, using ancient genome sequencing technology considerably more advanced than anything available when Hanihara first proposed his dual structure theory back in 1991. Researchers successfully sequenced 12 ancient Japanese genomes drawn from human remains excavated across 6 archaeological sites throughout western and central Japan. 9 of these individuals were connected to various periods of Jomon culture, providing researchers with genuine ancient genetic data to test against Hanihara's original model directly, rather than relying solely on skeletal measurements as the original theory had. The remaining 3 individuals came from the Kofun period itself, the exact historical chapter nobody had previously thought to test at the genetic level. When researchers analyzed these 12 genomes together, the Jomon individuals behaved exactly as expected, confirming their status as a genuinely distinct, deeply isolated ancestral population, having become genetically separated from mainland Asian populations somewhere between 20,000 and 15,000 years ago, precisely the period when rising sea levels permanently severed the Japanese archipelago from the surrounding continent. Genetic evidence suggests the Jomon maintained a remarkably small population throughout this isolation, estimated at only around 1,000 individuals sustained across many thousands of years, surviving as hunter-gatherer fishers, largely disconnected from the outside world, until the Yayoi arrived roughly 3,000 years ago and began the process of genetic blending that would eventually produce later Japanese populations. But the 3 Kofun period genomes told a completely different story than researchers expected. Rather than representing a straightforward genetic mixture of the already established Jomon and Yayoi populations, these Kofun individuals carried an additional, previously unaccounted for genetic signal, one connecting them closely to broader East Asian populations, matching genetic profiles found among present-day Han Chinese populations specifically. This additional ancestry could not be explained simply as a stronger dose of existing Yayoi ancestry. It represented something new entirely, a genetic contribution that had apparently arrived in Japan sometime during the Kofun period itself, centuries after the original Yayoi migration had already taken place. This is precisely the moment this 30-year-old scientific model quietly fell apart. Researchers tested this finding rigorously, running statistical comparisons between a simple 2-population mixture model and a more complex 3-population model that included this additional East Asian genetic component. The 3-population model won decisively, fitting the observed genetic data considerably better than the older dual structure framework ever could. It's worth briefly explaining how researchers actually arrived at this kind of confident statistical conclusion, since this is precisely the kind of rigor that separates a genuine scientific discovery from a merely suggestive pattern in the data. Researchers used formal, statistical modeling techniques that essentially calculate the probability of observing a specific genetic dataset under several different competing ancestry scenarios, then compare how well each scenario actually explains what was observed in reality. When the 2-population Jomon Yayoi model was tested against the Kofun genome specifically, it consistently failed to adequately explain the additional East Asian genetic signal detected within them, no matter how researchers adjusted the proportions of Jomon versus Yayoi ancestry within the model. Only by explicitly adding a 3rd, separate ancestral population into the statistical framework could researchers produce a model that actually matched the real genetic data collected from these Kofun individuals, providing the kind of rigorous, quantifiable confirmation that distinguishes a genuinely established scientific finding from simple speculation based on a handful of unusual-looking genetic results. Japan's ancestry, it turned out, was not built from 2 chapters of migration, but 3, Jomon, Yayoi, and now Kofun, this last component representing an entirely hidden wave of population movement that had escaped detection for 30 years, simply because it left behind no obviously distinct skeletal or cultural marker capable of separating it from the Yayoi population that had already been established in Japan for centuries beforehand. If uncovering a genetic secret hiding for 30 years behind a settled scientific theory fascinates you the way it fascinates me, make sure you're subscribed, because there are many more carefully researched deep dives just like this one still waiting to be explored right here on this channel. This discovery connects in a genuinely satisfying way to physical evidence. Archaeologists had already been studying from Kofun burial sites for decades without ever suspecting a genetic story lay hidden alongside it. Kofun-era burial mounds frequently contain imported bronze mirrors, ceremonial swords, and other prestige goods clearly originating from mainland China and the Korean peninsula. Physical proof of exactly the kind of close diplomatic and trade relationships historical Chinese and Korean records described during this same period. Prior to this genetic study, historians generally interpreted these artifacts as evidence of cultural and political exchange, elite Japanese rulers acquiring prestigious foreign goods through trade and diplomacy, rather than evidence of genuine population movement. The genetic findings suggest something more, that this same period of intensified contact with the Asian mainland was accompanied by actual people moving into Japan and contributing meaningfully to its population, not simply objects and ideas traveling along established trade routes, while the underlying population remained genetically unchanged. There's a particularly moving individual example that helps illustrate exactly how much has changed in scientists' understanding of Jomon ancestry, specifically, quite apart from the Kofun discovery itself. One well-studied Jomon genome recovered from a woman researchers call IK002, who lived roughly 3,500 years ago during the final Jomon period, was used to digitally reconstruct her likely physical appearance based entirely on her genetic code. The resulting reconstruction depicted a woman with dark skin, brown eyes, and distinctly curly hair, features that reportedly surprised many members of the Japanese public, who had perhaps unconsciously assumed their most ancient identifiable ancestor would closely resemble people living in Japan today. Her genome also revealed she likely lacked the genetic tolerance for alcohol commonly found among many present-day Japanese people, a reminder that the Jomon population, one of the two ancestral components everyone already knew about, still held plenty of its own surprises even before the Kofun discovery came along and added an entirely new chapter to the story. Once researchers confirmed this hidden Kofun ancestry existed, the next natural question involved figuring out exactly how much of it modern Japanese people actually carry today. Subsequent research estimates that, on average, only around 10% OF, the genetic ancestry found among people living on the main island of Honshu, traces directly back to the original Jomon population, with the remaining 90% split between the later Yayoi and Kofun migrations. This proportion is not uniform across the entire Japanese archipelago, however. The Ryukyu Islands, stretching south from the Japanese mainland toward Taiwan, show the same three-part ancestral structure, but with a meaningfully higher proportion of Jomon ancestry preserved among the population there, reflecting the region's comparatively greater isolation from the mainland migration routes that carried Yayoi and Kofun ancestry into Honshu more directly. A later, considerably larger genetic study conducted by researchers at Riken, one of Japan's premier scientific research institutions, expanded on these findings using a much broader dataset of modern Japanese genomes, uncovering additional regional genetic clusters roughly corresponding to Okinawa, the Tohoku region in Japan's northeast, and the Kansai region in west-central Japan, each reflecting slightly different proportions of these same three ancestral components based on regional migration and settlement history. This same expanded research also uncovered something entirely unrelated to the Jomon Yayoi Kofun story, but nonetheless fascinating: traces of ancient interbreeding with Denisovans, an extinct distant relative of Neanderthals, originally identified through DNA recovered from a cave in Siberia. Certain Denisovan-derived genetic segments still present within modern Japanese genomes were found to be specifically linked to present-day health outcomes, including variants associated with type 2 diabetes risk, a reminder that Japan's genetic history runs considerably deeper than even this newly expanded three-part model captures, stretching back tens of thousands of years before Jomon, Yayoi, or Kofun ancestry ever entered the picture at all. Taken together, this body of research offers a genuinely important corrective to the popular narrative of Japanese genetic homogeneity without diminishing anything genuinely distinctive about Japanese culture, language, or historical continuity. Japan's remarkable cultural cohesion, its language, its traditions, its historical continuity stretching back many centuries, remains entirely real and entirely worth appreciating on its own terms. What this research changes is our understanding of the genetic foundation underlying that cultural cohesion, revealing it as considerably more layered than a single, continuous, unbroken bloodline extending backward into deep prehistory without any additional interruption. Instead, Japan's population represents the product of at least 3 distinct successive waves of migration, arriving across thousands of years, each contributing its own genuine chapter to the country's deep ancestral story. There is something worth sitting with in how this particular scientific correction unfolded, because it illustrates something valuable about the nature of scientific progress generally. Hanihara's original dual structure theory was not bad science. It represented a careful, reasonable interpretation of the best evidence available at the time, skeletal measurements and archaeological context, in the absence of the ancient genome sequencing technology that simply did not yet exist when he first proposed it back in 1991. 30 years later, considerably more advanced genetic tools allowed researchers to test that same theory directly at the molecular level, and in doing so, uncovered a genuinely hidden chapter of history that no amount of skeletal analysis alone could have ever revealed. This is precisely how legitimate scientific understanding is supposed to progress, not through stubborn attachment to old theories, and not through reckless abandonment of them either, but through careful, patient testing against new evidence as better tools become available. It is worth remembering that Hanihara himself, working entirely from bone measurements decades before ancient genome sequencing was even conceivable, still managed to correctly identify the broad outline of Japan's layered ancestral history, correctly recognizing that at least 2 distinct populations had combined to produce the Japanese people. His model simply could not have detected a third, more subtle wave of migration that left behind no obvious skeletal signature of its own, a limitation of the tools available to him rather than any failure of his underlying reasoning or methodology. So when we say scientists were wrong about the Japanese and that DNA reveals a hidden third ancestry, this is exactly what we mean. For 30 years, the accepted scientific consensus recognized only 2 chapters within Japan's deep genetic history: modern. Ancient genome sequencing has now confirmed a third, previously invisible chapter, tied directly to the same Kofun period that gave rise to Japan's earliest centralized political authority, revealing that the formation of the Japanese state itself was accompanied by genuine population migration, not simply the political and cultural transformation historians had already documented through other means for well over a century. Somewhere beneath Japan's massive keyhole-shaped burial mounds, and within the genomes of well over 120 million people living across the country today, lies this quietly hidden third chapter of ancestry, invisible to archaeology and history, alike for 30 years, and finally brought into full view through the patient, careful work of modern genetic science. Scientists did not simply update an old theory with minor corrections. They uncovered an entire additional wave of ancestors, hiding in plain sight within a period of Japanese history that everyone already believed they fully understood.